So last time we talked about parabolas, and the first question that was part of the assignment, again, it was only 6 questions. The first one wants you to graph the equation y equals 2x squared plus 4x minus 5. I'm going to just do this one question at a time because I need room to draw. Based on what we talked about last time, and I know maybe it's not the most fresh thing in your mind, but there's a couple different strategies we could go for when it comes to graphing this quadratic, which should be a parabola, which is what the title of the section was. Anybody got any ideas on one of the strategies we could use, or what they think is maybe the easiest strategy to use?
We have to convert it to vertex form.
Convert it to vertex form. Okay, we talked about that last time. Good. And do you guys remember the name of the process that converts a quadratic in standard form to vertex? Okay, so mainly there's 3 forms of quadratics. There's vertex form, there's standard form, and there's factored form. And right now we have this one in standard form. To graph it, we could go to vertex or we could go to factored. So if you think it's easier to put it in factored form, you actually could do that and you would still get a piece of what the graph looks like. But to get the full picture of what it looks like, you really need to do both. Yeah, honestly, I'd probably say both. The process that changes a graph from standard form to vertex form is called completing the square. We did that a couple times last time. And the process that the processes that switch a quadratic from standard form to factored form are really just called methods of factoring. I guess you could just call it factoring. I don't know, but there's so many, but it depends. It depends on what your quadratic looks like, depending on which strategy you use. The one that would be appropriate in this case would be called the sum product method. The sum product method is only appropriate in factoring when there is no number. There's no number in front of the x squared. So a is equal to 1. Remember, there's an a, b, and c there. A is equal to 1, b is equal to 4, c is equal to -5 in this quadratic. So the sum product method is only appropriate when you have no number in front of your x squared and your b and c can be multiplied and added together and equal the same, or well, let me rephrase that. I should be able to multiply, wait a second. That's not right. I should be able to multiply the two numbers, multiply 2 factors of 5. So the 2 factors that equal 5, but when I add or subtract them, they equal 4. There's actually -5, right? So the only combination of factors of 5 that exists is 5 and 1. And the only way to make a 4 out of that would be to have a +5 and subtract 1. So the factored version of this quadratic is x plus 5 and x minus 1. And when you factor your quadratic, you are finding what are called the x-intercepts or roots. roots or solutions. They call them lots of things. Roots, solutions, x-intercepts, zeros. They also call them zeros because it's where y equals 0. So you would have one x-intercept at 1, and the other one would actually be at -5. So remember, when you factor into these two sets of parentheses, you have to set each section of parentheses equal to 0 and actually flip the sign to find where it hits the x-axis, which would actually be -5 and +1. Any questions so far on how I'm figuring out the graph for this so far? So I did it a little different than what Stanley said. I factored it first. That's not what I wanted. I factored it first, but now next I'm going to put it into vertex form. Because I really, just like you would need 2 points to graph any linear function, you actually need 3 points to graph any parabola. You can have any 3 points on a parabola and you'll be able to sketch the shape of that parabola. But only 2 points is not going to give you enough information because you need to know what that other symmetrical side looks like. So we got 2 points from the factored version. Now let's complete the square and find what the vertex is. Now there's a couple ways to go about this. We could complete the square and find what the vertex is that way. Or we could use the original equation and just test different numbers until we find one that equals the vertex that we need. I'm going to complete the square because we probably should practice that process anyway.